Hello and welcome to the British Tech Guru YouTube channel. My name is Zafel Beeblebrox and I'm your host. Well, today I want to talk about several things. First off, I've been working on my drone, and if you remember, I controlled a servo motor in the last video. Well, in this video, here is the Raspberry Pi, and I have an accelerometer here. Don't know if you can see it properly. There we go. Anyway, that accelerometer took forever and a day to get here. It was one I ordered from China. Now, the only reason I ordered it from China was shipping was free. It was a $3 item. And for the same $3 item, if I bought it from somewhere like Pi Shop, then I'd have probably spent $10 on postage, or had to bump the order up with a load of other things that I really don't need, just to bump it up to get free shipping. So, not worth it. That's why I use eBay so much. Anyway, the other matters. From China, for the radio project, I had ordered 2 solar panels, very small solar panels. Well, I had an email from the seller, and it said, oh, we couldn't provide this panel. Well, not quite. They said it had been sent back by the shipper as being damaged. Okay. Why wasn't it listed as being shipped on their tracking number that they gave me? Why did they wait 2 weeks to tell me this? Is it fishy? And I said, well, I just don't believe you. And they came up with so many different reasons, not just the damage in shipping. And I was just looking at it and thinking, well, there's something not right there. So I looked at it, I thought, okay, let me give them a negative review. So I did. I gave them a negative review based on exactly what they had told me. And the next thing they said, well, look, let us refund your money and we'll pay you an extra $3 on top to give us a good review. What? $3? To give a fake good review? I think not. Or as the French would say, mais non. So I said to him, well, look, it's supposed to be delivered by the 7th of July. On the 7th of July, I can file against you for non-delivery anyway. So I can just afford to sit it out and wait. So I'm just waiting for what they do next. They could send the items. I doubt it. They could send me a refund. I doubt it. Or I could have to wait until the 7th when their time runs out, and I just file with eBay for non-delivery. That's fine with me. Going to hurt them more because they're a small seller. In fact, I think they're a scammer. I truly do believe they're a scammer. They got 5-star reviews for less than 50 items. They probably had all their friends write good reviews and made straw sales. Anyway, that's eBay. Now this accelerometer, I had a whole lot of difficulty finding software that would make it work, and I must admit I am not very familiar with I2C, which this uses. It's a communication protocol using 2 wires and multiple devices on those wires. That came out in the 90s when I was in college, so I should remember it, but I don't. And what I've done is I've hunted and hunted and hunted, and I found a lot of software allegedly for the Pi Pico and for the same or similar accelerometer, none of which actually worked. Finally, and I spent most of the day yesterday hunting, finally today I found some that actually worked. And the big difference is, all day yesterday I was using Google as my search engine. Couldn't find it. Used DuckDuckGo, found it. Maybe there's a hint there. Anyway, I shall show you the software now. As normal, we're going to start by opening Thonny. So we're going to go Programming, Thonny, and we're going to open the Raspberry Pi, which comes up as the MicroPython device. Now there's a whole load of different bits of software I've tried on this. This is an interesting one, because this didn't work on just about every of the virtually every version of the IC2 test, I2C test did not work, and this one actually does. So if I go like this, it tells me I2C devices found, 1 decimal address 184, hex address, yes, and maybe I should be wearing my glasses. So that works. So we'll close that. Now we're going to go back to the MicroPython device and test 4050. It should be 6050. Okay. Now that is the software to test or to work with the accelerometer. There was a bit more involved. Let me see if I can view. View files. There we go. Put that down. There was something called vector3d.py and imu.py. Now all this came from another website, and if I open that, you can see that it comes from GitHub, and that this was written by Peter Hinch and Sebastian Plaumer. So I cannot claim this is my own work. I have done none of the coding on this. This is strictly as it came today. So I'm not going to make any claims about this, other than this bit of code I can modify and include in my own code, and that I probably will. So what we're going to do is we're going to set it running, and you can see that the temperature outside is 36.79 centigrade, and you can see the x-axis and y-axis and the z-axis. So if I pick up my accelerometer, I'm now tipping it to the right. You see how it all changes? I now tip it to the left, and you see how it changes? I tip it forward and it changes. I tip it back and it changes. And then I'll tip it at a strange angle, a couple of strange angles. There we go. And we'll just put it down again. And you see that works really well. So that is all I'm going to show you there, because that works, and it works well, and I'm very happy with it. So I'm going to stop that, close this, and so that was all. So that was all fairly simple. I have to admit I did none of the coding. I just looked it up. But then part of coding is knowing when not to code and when to just look things up. And it works, so I feel happy using it. And I've glanced through the code, and there's nothing in it that gives me concern that it might be it might have some backdoor exploit. Now, one thing I want to do is I want to give a good shout out to some good friends of mine that have been friends for a very long time, the South Wales Linux Users Group. And I'm sure they could do with a few members, and if you're in Britain, go along. And I'm the only long distance contact, and I'm only welcome because I was a member before. And I think some of them are a little upset that I'm telecommuting. But this is a great users group, and I can recommend it. Locally, I've yet to find anybody in South Carolina that is in some kind of Linux users group or Raspberry Pi users group, anything like that. I do understand that a Raspberry Pi went up into space as a CubeSat recently, and it flew for 117 days before they deorbited it. And apparently it proved itself as a very stable $10 satellite. Well, imagine the cost of all the other satellites. When you can send a satellite up for $10 that works, and it's $10. It's going to put the willies up a lot of the satellite makers. But back to the main topic. You have now seen the accelerometer being used. That will be used together with the servo or servos that can keep a drone in level flight with no problem. Add some GPS, which is coming, and an altimeter, which is coming. I have a BMP 280 altimeter. It's actually a barometer, but same difference. It all works on air pressure. I have to say though that the altimeters are not really much good below about 1,000 feet. Below about 1,000 feet, they're not very accurate. But it is what it is. This is why, of course, the real drones, and I'm not talking about Hitler's V2, because the V2 was totally different. The V2 was just programmed, mechanical programming to fly along a set flight path at a set altitude. And I do believe they used a barometer as an altimeter, and I think they set it to fly at about 3,000 feet. The current cruise missile does not use a barometer altimeter. It uses an audio altimeter. It sends out noises at different frequencies, and if you've listened to a cruise missile going past, as I have, then it has a wide frequency sweep of noise, and it bounces that noise off the ground. And the different frequencies bounce off different things at different rates, and it just averages those out to get a good idea of how high it is. And it travels about 80 feet, which means that the sound has to travel about 160 feet. And of course, bearing in mind the speed of sound, which travels at, I believe, 330 meters a second. Sorry, confusing you now. I'm using meters and imperial, metric and imperial. I remember it as being 330 meters a second, which is 330 yards a second, or 990 feet a second. So the sound, the cruise missile cannot fly faster than the sound takes to return to it from the ground. Bear in mind that the sound has to go down at an angle, bounce up, in order to be received by the missile, which is now a little bit ahead of where it's, quite a bit ahead of where it emitted the sound in the first place. So the sound has to go bing bong, Now there is an argument for using lasers for altimeters, and the problem there I can see is what happens over water or over sand, sand or even reflective surfaces. Might not be so accurate, might not work, but for the ordinary average hobby drone probably works just fine. LiDAR seems to work. Anyway, that's about all I have for you today. Oh, I will say that I got in contact with one of the guys that wrote the software that didn't work for the Pi Pico. He was a little bit perplexed by it. But in all these things, they seem to call for I2C as an import. It's already in machine. It doesn't need to be imported. So, anyway, it is what it is. And I'll see you in the next video. Or you'll see me in the next video, whichever it is.